Hello, statistics students. In this video, we're going to talk about a couple of more graphs. Now, as you can see here, I've listed them into biggies and not so biggies. The graphs that we use a lot and the graphs that we don't use so often. Now, we've already covered how to make histograms and stem plots. We actually used box plots on our farming project, but I haven't really taught you what all the components of a box plot are yet. Today, in the world's briefest video, we're going to cover these three graphs. Now, if you're interested in these others, this is good news. Here's the page numbers for you in our current textbook. The Pareto diagram is pretty interesting. It's used in statistical process control. What you do is you rank order their qualitative variables, and you do a bar graph of them. So the height of the bar represents your frequency, but you put the bars in order from tallest to shortest. So what that allows you to do is it allows you to identify, if we're doing it in statistical process control in a manufacturing environment, we're looking at where are our errors, our rejects coming from. And you look at where the biggest bar is, the tallest one, and say, okay, that's where most of my problems are, and you tackle that one first. So I encourage you to read these three because we will reference them once in a while, but let's learn how to draw these. So a bar graph is qualitative or categorical data. Now, there's no reason to put the bars in this order, except, of course, brown-eyed people are the best people. But other than that, no real reason. You could put them in alphabetical order or any order you want. So in a bar graph, it is customary to leave spaces, evenly spaced gaps between the bars. And your category, or whatever your variable is recording, goes down here, and the height of the bar represents your frequency. Now, I included in other. You don't have to in a bar graph. You could just say those are the three most common eye colors. And that would be fine for a bar graph. I put other because now I've included all eye colors. Another type of categorical graph is a pie chart. And in a pie chart, each slice of the pie represents a fraction of the whole. So you can't, if we were doing these eye colors, you can't leave off the other, because now this as a fraction of just these three is different from this as a fraction of all four, and all four is all possible eye colors. So my example here would be, let's say that we were taking a survey of the senior class and saying, who's your favorite bald statistics teacher? 40% of the people surveyed said Mr. Miller, 35% gave somebody else who's not even a bald statistics teacher, et cetera, et cetera. If you look at each response on that question, 40% of them had one name, 35% had another. And maybe this 5% was other. Maybe there was a long list of bald statistics teachers out there where they all got a vote apiece. But the point is, if we didn't include this other category, we'd really be in a problem. Because then it would be 40%, 35, 20, that would be 95%. Well, something's missing, because a pie chart always has to add up to 100%. The last type of chart I'd like to talk to you about is a scatter plot. A scatter plot we want to see visually. if there is a relationship between two quantitative variables. So on one axis, I have one quantitative variable, which would be height. The other one, I have weight. Then each data point represents a person where their x coordinate is height, the y coordinate is weight. Now, in general, the taller people are, the more they weigh. Sure, there are people who are really tall and don't weigh much. Sure, there are people who are really short and weigh a lot. But in general, you know, the taller you get, the more you weigh. So I would look at this and look and say, okay, these two are a little bit crazy. But in general, as x gets bigger, y is getting bigger. There's a positive slope here. And next semester, when we talk about scatter plots, we'll talk about ways to describe this. But for right now, we just want to know that a scatter plot is for quantitative variables. Each coordinate, the x coordinate is one of those variables, and the y coordinate is the other variable. And each data point is one, whatever it is you're measuring with those two variables. That's all I have for you now. Have a great day.